All right, continuing on with 10.4 part 1, all right. In example B, all right, here you're given two foci and an asymptote line, right? And so what I did was I plotted the foci. Hopefully we can tell that the center, right, is going to be at 0, 0 again, all right? And because the foci are vertical, right, that means that the equation, right, and here we're going to start this off, equals 1, right? That means the first numerator is going to be y squared, okay? Because remember, the variable of the first numerator tells you which way the hyperbola is open, okay? Now here, y equals negative x, right? We can also say that that's y equals plus or minus 1x, right? It has the invisible coefficient of 1, right? That means one of the asymptotes looks something like, this is bad, looks something like this. Right, there we go. Okay, that means the other one's gotta be y equals positive x, right? Okay. And so, well, that must mean that if it's 1, right, that means A and B have to be equal to each other, right? Because remember, for the asymptote line, right, in this case, it's y equals plus or minus A over B, okay? But if we know that the slope is 1 and negative 1, the only possible solution or, logical conclusion is that A and B must be equal to each other, all right? So let's see. We know that from the center to a focus point is a distance of 2 units, right? So that's your C value, right? C is equal to 2, okay? Then we also know this little formula. C squared is equal to A squared plus B squared, right? If C is 2, then C squared we know is 4. So this is 4 is equal to A squared plus B squared, okay? Now, if it equals 4, right, then that means each of A and B have to be root 2, right? A is going to equal root 2 and B is going to equal root 2. Because when you square those, right, when you square this square root of 2, that's how you get 2. And then 2 plus 2 is going to be 4, all right? And so that means A squared is 2 and B squared is 2, right? And those are going to be your denominators, 2 and 2, and we know the other missing variable is going to be x squared, okay? So it is possible that A and B can be the same for hyperbolas, okay? All right. Again, if you have questions, please let me know. If you need to rewind and watch that again, you can certainly do that as well. Okay, here in this slide, you have these in your notes, or it's in the note solutions as well, but we're going to look at hyperbolas where the center is not at 0, 0, okay? And I'm going to remind you of point slope form for the equation of a line, and that's actually going to be more helpful than y equals mx plus b, all right? And so I'm going to walk you through that in this next example here, okay? All right, so it says find the equation for the hyperbola described below. Graph A, that's supposed to be sketch of the hyperbola. So I kind of sketched out some points here. All right, we've got a center at -3, -4. Okay, that's going to be the center. You've got a focus at -3, -8, and then a vertex at -3, -2. So you got to realize that the vertex here given to you, right, and the focus given to you, these are opposite direction parabolas, right, that make up the overall hyperbola, okay? And so let's see, from the center to the vertex, that's going to be the A value, right? And what is that a distance of? I believe that's 2, right? It's a distance of from -4 to -2, right? So the A value is going to be 2, all right? And from the center to the focus down here, right, that's going to be from -4 to -8, right? That's your C value, right? That's going to be 4, okay? And so we need a B value, right? So we're going to figure that out. C squared is equal to A squared plus B squared. 4 squared is 16. 2 squared is 4. Okay, so B squared is going to be 12. All right. Now, B itself is the square root of 12, but remember, we're going to simplify, and that's going to be 2 root 3. All right, so B is 2 root 3. Okay. Now, we actually have enough information to write the equation. All right. Make it a little bit longer here. Okay. Remember, A squared is always the first denominator, so that's going to be 4. Okay. B squared was 12, so that goes here. All right. Now, because of the way that these points are lined up, right, these are vertical, right, and so we know that the hyperbola is going to open up and down. Okay. So therefore, I'm going to make sure that my first numerator has the y, and the second numerator is going to have the x. Okay. Now, since the center was at -3, -4, this is going to be y plus 4 squared, and then x plus 3 squared. Okay. And there's the equation. All right. So now we need to graph this. Okay. I need another vertex point, and I'm going to go 2 units below the center, and that's going to be here. Okay. Now, we need a calculator here for this because 2 root 3, all right, we need an approximation here. That's going to be about 3.5-ish, all right? So from the center, we're going to go about 3.5 out. This is going to be 1, 2, 3, maybe right here, if we guesstimate, okay, and about here, all right? So we're going to draw that rectangle, right? Connecting there. All right, and then the asymptotes are going to come from the diagonals. Okay. So there we go. I know it's a little messy. Apologize for that. All right. So the curves, remember, you start at the vertex and then use the asymptotes to guide your curves, right? This is very poorly drawn. I apologize for that. Okay. All right. So it didn't say anything about the asymptotes, so we're going to forget that for now. Okay, so in this one, you're given an equation of the asymptote, all right? And I already sketched out for you what's going on here, okay? You've got a center at 2, -3. This is the center. And you've got a vertex at 2, 2, okay? And so that's a distance of 5, right? So then what I did was, from the center, I went down 5 for my other vertex, okay? So that's your A value, right? The distance from the center to a vertex, right? That's your A value, okay? Now, take a look here, all right? Look at this slope, right? this equation is in point-slope form, all right? And 5/2 represents the slope of the asymptote. Well, we know that a is 5, right? And so there it is, right? That's your a value, which means that the 2 is going to be your b value, all right? All right, that's going to come in handy later, okay? So for now, we actually have enough information to write the equation of this hyperbola, all right? Again, we can tell that the hyperbola opens up and down, right? So I'm going to make sure that the first numerator has the y, okay? And the first denominator is always a squared, which in this case is 25, all right? The second numerator is going to have the x, and that's going to equal 1, right? B squared, we know is going to be 4. And so since we know the center is 2, -3, this is going to be y plus 3 squared, and then x minus 2. All right, so there's the equation, right? If we were to graph this, right, so the b value was 2, so that means from the center, I'm going to go 2 units this way to the right and to the left, which is here, right? And these 4 points I'm going to use to draw the rectangle, right here. Okay, and then again, the diagonals of the rectangle are going to be the asymptotes. All right, so there it is. Okay. So now we can draw the curves within the asymptotes. All right. Now it says find the foci of the above hyperbola. Okay. So we know that we're going to use this equation, right? So that's going to be 25 plus 4. So c squared, or c is going to equal plus or minus square root of 29, right? And so from the center, we're going to go up and down square root of 29, right? And so since the center was at 2, -3, that means the foci are going to be at 2, -3 plus or minus square root of 29. Okay. And again, you know, we need, when we plot, right, we need to go to the calculator to approximate the square root of 29. It's like 5 point something. I think around 5.4 maybe, 5.3. Okay. And so from the center, you're going to go up 5.4 units and go down 5.4 units. And remember, the foci should be farther than the vertex, right? Because it's going to be inside of the curve. Okay, so somewhere around here. All right. Okay. I know that was a lot to take in, especially going over it in a video. Okay. If you have questions, please let me know. We will go over any questions you might have in the next class period as we tackle part 2.